All right, so in the notes for 8.5, it's important that you see that we're not proving that the triangles are congruent. We're proving that parts of the triangle are congruent to each other. And so that's what the P in CPCTC stands for. It stands for corresponding parts of congruent triangles are congruent. And so it means that after you prove two triangles are congruent, you can use CPCTC as a reason to prove that a piece of one is the same as a piece in another. I want you to add a note onto your paper over here that says that it will usually be the last reason in a proof. So in these two examples, we're trying to prove that a part of this triangle is congruent to a part of this triangle. The reason why AD and BC are congruent to each other is because it's given in picture. It's kind of the same as just saying it was given, except they didn't list it as given typed. It was marked on the picture. The reason why DC and CB are congruent to each other is because that one was also given in the picture. The reason why AC is congruent to itself is because of the reflexive property of congruence. And so look at how this proof ends differently than the ones did that we've been practicing so far. Saying that the triangles is congruent isn't what you're trying to prove. That's the next to last step. So it happens before the new CPCTC reason. Triangle ADC is congruent to triangle ABC because of side, 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 because the three sides of one triangle are congruent to the three sides of another triangle. And then the thing that you're trying to prove, that angle D is congruent to angle B, is because you just said the two triangles were congruent to each other, and so now you know all the other parts of them are congruent to each other. So that's the reason that you can write down is CPCTC. It'll usually be the last reason in a proof, and it proves that the triangles are congruent to each other. So anytime you're doing a proof and you see that the last thing is not saying that the triangles are congruent to each other, that's usually your clue that you're going to be using CPCTC in your proof. On number 2, angle G and angle I are right angles, and so that's given in the diagram. You can say given in the picture, or you can say given in the diagram. Angle G is congruent to angle I. That's because all right angles are congruent. This is also called the right angle congruence theorem, but you can just write out the words if you want to. Angle E is congruent to angle J. That's given in the diagram or given in the picture. And EF is congruent to JK or KJ. That's also given in the diagram. So let's look and see what we have. So these two angles are congruent, the two right angles are congruent, and then this side's congruent to this side. So even though they're right triangles, notice I never said they were right triangles over here. I'm not going to use HL. This one is angle, angle, side. I know these two angles are congruent, I know these two angles are congruent, and I know that the side, one of the sides that's not in between them is congruent on the other one. So the reason the triangles are congruent is angle, angle, side. The reason that side EG is congruent to side JI is because I just proved the triangles are congruent, which means the other pieces of them are congruent. And because of that, corresponding parts of congruent triangles are congruent. The reason why these two pieces are the same is because of CPCTC. So again, remember, it's usually going to be the last reason in a proof. Alright, so here we're going to practice some proofs that use CPCTC. And remember, your hint that you're going to use CPCTC on this one isn't because of something you see on the paper up here, it's right here. Because you're not proving that the two triangles are congruent to each other, that means that you're probably going to prove that the two triangles are congruent to each other, and then you're going to finish the proof with CPCTC. So remember, go ahead and write in your givens. The first given is that triangle LMN is an isosceles triangle with vertex M. And then it says that ML is congruent to MN. The reason why those two sides are congruent to each other is because that's what the definition of isosceles triangle is. It says that the two sides that come down from the vertex angle are congruent to each other. So the definition of isosceles, and you can say isosceles triangle if you want to, but you could just say definition of isosceles, is that those two sides are congruent to each other. Let's see, the next one's given. And then LP, so if MP bisects LN, that would mean that from L to P was the same thing as from P to N. And so that one is definition of bisect. So you could also write definition of segment bisector. Both of those would be fine to include there as definition. The reason why MP is congruent to itself is because of the reflexive property of congruence. That says that the side that's shared is the same on both. And so if you were just trying to prove the two triangles were congruent to each other, you would be finished. And the reason why the triangles would be congruent to each other would be because of side, side, side. But this proof takes it one step further. The reason why angle LMP, this angle right here, is congruent to angle NMP, this angle right here, is because of CPC, TC. You prove the triangles were congruent to each other, and then you conclude that a part of one triangle is congruent to a part of the other. And for the final one, don't let the length of the proof bother you. Look at this one. You see how there's 1, 2, 3. So I'm going to go through and I'm going to find the things that are given to me first, just because it kind of helps me to feel like I'm writing down things. Let's see. Here's my third given. All right. So side AB is perpendicular to side BC, and side CD is perpendicular to side BC. And then it says that these two angles are right angles. It's not because they look like right angles. It's because of the definition of perpendicular. That's what perpendicular means, is that they intersect to form right angles. And then angle ABC is congruent to angle DCB because both of them are right angles, and because all right angles are 90 degrees, which means that all right angles are congruent. And remember, that's called the right angle congruence theorem, but you don't have to name it by name in this class. It's okay to just write down the words for what it means. A is congruent to D because we were given that information, so let's mark that on the picture. And then BC is congruent to itself. That's because of the reflexive property of congruence. And so triangle ABC is congruent to triangle DCB because these two angles are congruent, the two 90-degree angles are congruent, and then this side of this triangle is congruent to this side of this triangle. It's not the side in between the two angles that you know. So that's angle, angle, side. Remember, just because they're right angles does not mean you're always going to use HL. And then we're trying to prove that side AC is congruent to side DB, and so the reason for that is CPC, TC. I proved that the two triangles were congruent to each other, and now I am concluding that a part of one triangle is congruent to a part of the other triangle, and that's because they correspond.